UGI Terra software is used to process the imagery, and you could generate 2D models if needed, and you could do data analysis to identify the vegetative indices as well as crop health. So if you fly that over extensive area, you could already identify, okay, there may be a little issue in certain areas, and many times in the Caribbean, that might be useful, particularly because of the diversity of soil types and topography and so on. Many of us would know that some of our countries have very, very diverse soils. So in a 10-acre plot of land, you might be dealing with 3-4 different soil series. And sometimes, even though you have the same management practice across the whole farm, you will have different results. It may not necessarily be that you're doing something wrong. It may just be that you're on different soil types. Yeah? Right. What are the challenges? Well, it's expensive, which I already talked about already. Right? There's also limited battery life and payload capacity in some of the drones. It's high cost for smallholder farmers. You cannot expect an individual farmer to really invest in this. Even if they purchase this, then the software, then processing, it is something that has to be supported from a higher level, in my opinion. Then you also have regulatory constraints. So beyond visual line of sight flights, right? Sometimes if you have mountains and so on, it tends to, depending on the type of drone, it could lose connectivity and it could lose your 5,000–6,000 US investment. You also have certain regulation. Different countries may be slightly different, but you know, like you can't fly close to an airport, for instance, no-fly zones. Some of the DJI drones, as soon as they connect to the internet, you cannot fly them above 120 meters. So what you have to, everything has a hack, right? It's 120 meters from where you set the drone up. So if you go on top of the building, you gain 40 meters, if you get what I mean. So sometimes if you go in the field and you have that problem, you look for a hill with that clearing and you set it off from there. Yeah? Right, and obviously there's a need for training and capacity. I do not believe, if some farmers can do it, yes, but I do not believe that the training and the capacity building should be done at a smaller farmer level. I believe something should be designed within countries to support collecting that data and providing the farmer with the information. I think that's it for me. Let's play this video. This is actual real drone. All right, thank you all very much.
Thank you, Dr. Rupnarayan. Just to let you know, he is the Deputy Dean of Outreach and Internationalization and a senior lecturer at University of the West Indies, St. Augustine campus. And he will take questions afterwards when you meet him always. All right, thank you very much. We are going to move quickly now to one of our online speakers, Dr. Kimberly Baldwin. Dr. Baldwin, are you online? Can you hear me clearly?
Yes, sorry, I was unmuting myself. Yes, I can hear you, Ramon.
I can hear you as well. So Dr. Baldwin is a marine ecologist, geospatial analyst, and a drone educator with over 25 years experience in the area, especially with management systems across the Caribbean. And she's going to present to us on behalf of the FAO how we're building capacity using geospatial tools in the Caribbean. An interesting presentation for the work we have been doing in partnership with Dr. Baldwin. Kim, the floor is yours.
All right.
Keeping it to like 5 to 10.
Okay. Can you see this, Ramarian?
Yes, I can.
Okay, I'm gonna mute myself and start the presentation then. So
Thank
just to give everybody some context, this is a drone training we did together, and this is actually results from the students themselves from the drone team in Dominica, showing sort of the results of their training.
For a small island developing state like Dominica, it's really important for us to look at our census as more than just the crops that is growing. We actually have to look at it as an agricultural ecosystem where we look at the spatial data as well as the social and economic situation in the area. That will include a participatory approach. We look at it as a participatory UAS framework for the agricultural census, where we'll look at the knowledge based in the community, the persons who are involved, as well as the GIS data we collect from the drones. There are several groups of information that we collect. The first being the core agricultural and land use data. Here we look at the size and the number of farms, whether or not it is cultivated, as well as the ecosystems, so any watersheds that are in the area, the elevations of the area, and any hazards that are associated. That will involve using the drone as a base map and integrating the information from the community themselves to complete it. We also look at the crop and livestock production data, the types of crops that is grown, estimated harvest that is expected, types of livestock, and any other innovative agricultural practices taking place in that area. We use field surveys as well as participatory drone mapping to validate this information. Then we have socio-economic data from farmers and the community, where we look at the demographics, the livelihoods of the persons, their participation in groups and cooperatives. This is actually when we look at how the members of the community integrate with the farming community. Then we look at the markets and infrastructure, at the conditions of the roads, the distance of the farms to the market, the distance of the farm to the post-harvest facilities, to the slaughterhouses, to any community points. We also look at things like the police stations and services offered by the ministry, so the livestock office, the regional office, and the farmers' access to these areas. Then we have the environment, disaster, and climate resilience data. A lot of this will come from the drone imagery as well as our GIS data sets, the different models that we have already available. This is where the data from the Met Office, the data from Land and Survey comes in. We also look at the vulnerability, mapping the areas where we've had extreme hurricane damage, wind damage, water damage, etc. And then we have additional data sets that are important. So the legal status, registration of the land farmers, any digital platforms, the agro-processing in the areas. This is where the integration between the different parts of the ministry, so agriculture, environment, climate, the different offices, and how we share the same data for different applications. To get an agricultural census, we actually needed to look at what type of data was necessary. It took a lot of brainstorming. We had some serious sessions using pen and a whiteboard, just trying to select what was the critical information that we would be collecting. To help us with that, we also used the Kobo toolbox because we had already been using that for data collection. So a lot of the subsets were already there, and we used that to assist us in creating our metadata table. Why did we have to do an agriculture census, or what is the importance? There are really a few important things that we have to look at, and it is for one, resource allocation. So when it comes to national planning and looking at what communities require, what infrastructure, where do we add money, where are the opportunities for investment, where are the high risk areas. It also helps us to support climate adaptation. And most importantly to me is where we get to look at the pre and post-disaster information, because when we go out and we do the census, we capture all of the information, and should there be a disaster, then it really doesn't take a lot to go out, recapture the new information and compare it to what was previously done to give us an accurate and timely assessment of the damages that has been done.
We chose soil as our pilot treatment. It's one of the most vegetable production posts in the area where almost every house had either a backyard farm, agroforestry, and the commercial plots. And some of the traditional farming and the cooperative in the area. We used them, the ground remote spectrum to apply. We had to create the KML, and then we translate to use that software. It comes with the pilot programs on the remote control. When we go to flat, we don't just go out and say, oh, we want to fly, and we don't take the drone and share it up in here. Sometimes we might even have to go in advance, look at the area to see what zones where we can take off from, where we can establish our flights. Dominica is a very difficult place to fly because most of the other islands they are flat, and Dominica will not like that. So flying sort of great. We encounter some problems with the when we fly. We have cliffs on both sides. So sometimes when you know which one flying over one side, it will drop. If you have the map, look at Pascal which flies. And the Gulf mosaic was 2.5. The resolution was 9 centimeters per pixel, and the accuracy was at 40 centimeters. The red area is the higher elevation, and was all the way down to the group. So we will use that to measure how we can manage our flight. Material would be appropriate to standard materials. We will need more precaution when flying. These are the annotation. The part I was extremely interested. If you see, this is our key, right? Let's consider the red areas is past the museum. That most of them and 3 clocks. Yeah, on areas, continuous that are unused and will find at that present time the uncooked watermelon and water table based on soil and capital. But you can actually all different type of fields. So right now that's the livestock grazing, so oranges are all passion fruit, exotic. You can just look at the map, so using that as part. When we go to football, we can have the names and point the locations of the farmers, so we can actually go back and see you got this from and that's where the farm is located. So whoever is looking at the map can actually know that the person has on the ground in real time.
So using manuscripting, we know the method table. We have featured classes, the geometry and the attributes. So in this, we have a breakdown of everything that we capture through Kobo. Each feature has been color-coded for annotation purposes. Site results, annotation, data sum. This is of a report that drone deploy puts clear for us in the backend. After putting in our annotations, you will see here that all the heavy lifting has been done. We can go in the backend, generate the report, and as you can see, you're able to download our CSV file. For example, question raising the entire area of this specific question and what the service area. And with the help of him, the data that we have is on AI. And it shows us that our number one crop here is tomato plants, watermelon, and then tree crop. We have livestock, and you can see everything that is related to what these features are, and then specific attribute infrastructure. At the end of the day, we need to know what we have at present, and for this, another small methods, we need to be able to account for this. And we put all these different areas together with the help of Dr. Kim. We have soil and agricultural data, potential vulnerability area, social activities, hazards, administrative and support layers, and secondary. Integrating the data from drone deploy and Kobo toolbox can significantly enhance data collection, analysis, and reporting for various applications. This integration allows for drone captured imagery and geospatial data with detailed field observation, creating a more comprehensive and precise data set. Benefits include improved accuracy, efficiency, accountability, monitoring, and evaluation process. We have all data gaps and additional surveys, as well as stakeholder validation and participatory mapping for farmers extension.
And the mapping frequency is the amount of times in a year we want to map that area so we slowly compare and contrast. The ideal time we thought would be 4 times a year because we no longer the most public frameworks. So the map was shocking with not anything new. We were going to take the same information, put it into the drone, and the whole thing wasn't even needed to be there to fly. Because we can't just send us the information and where was put just go on, but fly the map, send the information back and then provide the data. Or no, the time of before the start of the hurricane season and then when we start end of the hurricane season so we can have that data to compare.
Thank you, Dr. Baldwin. Any closing remarks before I? You're good. You're muted, though, Kim.
No, I'm just always so proud to see the teams after, to see how they apply their skills after doing the training. So that was an advanced training. The Dominica team was first trained in 2022, and that was a training we just recently completed, the advanced agricultural mapping training.
All right, thank you. And we really want you to get a sense of what the country feels like when they do the training and how they apply the data for the trainings, and a blended training, the boot camp almost, if I call it that. All right, we will take questions on the back end depending on time, but I want us to hear the presentations. We're going to now move quickly ahead, and I'm going to invite Dr. Hannah Whitman to present. And I believe Dr. Whitman is online with us as well. Dr. Whitman, are you online?
Yep, thanks so much.
All right, so Dr. Whitman is a professor at the University of British Columbia in the Faculty of Land and Food Systems, and is actively involved in the Center for Sustainable Food Systems, as well as the Center for Climate Justice and the Institute for Resources, Environment, and Sustainability. Dr. Whitman, the floor is yours.
Great. Thanks so much for having me here. I've just joined you from the Digital Agricultural Week in San Jose, Costa Rica at the IICA. And so I'm really excited to be able to participate in your event as well. So I've been asked to present about Light Farm, which is an open source digital tool for agro-ecosystem monitoring that we developed at UBC in collaboration with 10 organizations in Latin America who are doing participatory agroecological certification and working to do knowledge sharing with each other on transitions to agroecological food systems. So what we found in our research and in our long-term engagement with agroecological farming movements is that farmers are really needing help with understanding cost of production and decision support, especially for diversified farms oriented to local markets. They're really interested in easier ways to do sustainability reporting, so filling out forms for organic certification, payments for ecosystem services, greenhouse gas and soil carbon programs. And they're also really interested in protecting their data sovereignty and their data privacy. And from a research perspective, we really have a data gap in understanding smaller scale, complex, and diversified farms, which are much more complex than a lot of the commodity plantations, which can use precision agriculture or large scale machinery to have more data-driven decision support. So a lot of those tools aren't available for the smaller scale and diversified farmers, and really we need to develop a better evidence base for better decision making with real data from these complex systems. So I was really excited to hear about the drone project because that would be really nice. So right now, a lot of the way we capture data is through individual soil science projects or individual integrated pest management projects. There's very few projects that are actually looking at holistically how to assess the sustainability of an agri-food system. Farmers are often keeping data in really ephemeral ways. They're writing it on whiteboards, on pieces of paper, and they often then have to put that information into reporting systems that are also on paper. So here's an example of an agroecological certification program in El Salvador where farmers are actually drawing their farms on a piece of paper and using that for their certification. What happens when we try to pull all this data together? Often it's like a big data wrangling project. It's very much not done very often and very well to really look at the whole holistic outputs of these complex farming systems. So we worked with these groups of farmers to figure out what do these systems look like? What are the values and indicators that are important to them to measure, and how are they using this data to advance their own agro-ecosystem goals? Connecting with consumers, connecting with payments for ecosystem services, and connecting to actually make better decisions about their farming. So we developed an open source farm management tool. It's a fully featured farm management information system. It's available in multiple languages. And I can tell you a little bit about it, but you can certainly explore it online. It's free. First of all, we developed it for this project specifically, which involves about 550 farms from the 7 countries in Latin America that we have partnerships. But we found that enough farmers were finding this to be useful that we have people using it all over the world. So in more than 160 countries now, People have found the app online, they're starting to use it, and we're starting to do really interesting data analysis from really understanding the diversity and complexity of these really really diverse global food systems and how they're producing biodiversity solutions, they're producing climate resilient agriculture, they're producing food security in their local contexts. So I'll just spend a few minutes showing you what the app can do. So basically it's based on a mapping function. You can map your fields. You can, based on the principles of data sovereignty. So a farmer, you create an account for the farm, and then you can invite as many people as you'd like into that farm account. So a farmer is the owner of their own data. They can invite in a technician, they can invite in a service provider, they can invite in workers or family members. The farmer retains sovereignty over that data. So if an extension provider or service provider moves on, the data that that provider entered into the system stays with that farmer. So it's a way to stop the kind of cycle of taking data away from a farm and not having that be integrated longitudinally for long-term use. Farmers can create crop plans, manage livestock, create and assign tasks. So when you create a crop plan, there's a number of crop tasks that are automatically assigned. Service providers can also log in and assign tasks. So for example, if a pest is identified locally, technicians can push notifications to farmers using Light Farm saying, please scout for such and such a pest, please apply such and such a remedy to address that pest or disease. So you can use it for communication and extension support. It enables farmers to easily organize their finances and calculate their cost of production. So you can keep records of inputs and sales. And then you can store and document and export materials that are needed for various kinds of certifications. So these are some examples of just some of the screens in the app. So yield and profit analysis. We have an integration with iNaturalist, which is an open source biodiversity assessment app. So any biodiversity observations that are taken in the iNaturalist app can be visualized according to the specific farms in Light Farm. And so that's a nice way for farmers to communicate some of their contributions to biodiversity and ecosystem services. We are actively developing new soil health modules right now. They should be released in October. Soil samples, historical soil health records, and mapping soil input actions to soil health outcomes. We have an active integration with the Cool Farm tool, greenhouse gas calculator, as well as the Holos greenhouse gas calculator. This allows farmers to simply document their regular day-to-day practices, and then we're able to push those practices into carbon calculators that are specific to a specific location, soil, region, and that can be useful for documenting soil carbon contributions, and there is a growing soil carbon market. We have a dashboard and data visualization module, so groups of farmers, cooperatives, extension services can develop private, password protected dashboards for farmers that they're serving. And that's, we've seen really good uptake of that with our farming groups in Latin America who are using this kind of long-term tracking of the performance of the agri-ecosystems that they're advising to set up baselines, benchmarks, and communication back and forth between those sets of farmers. This is just a couple examples of some of the analysis that we're doing from the data from our Latin America project. We're able to look at the relationship between farm productive area, natural areas, yield, and nutrients provided. So really, it's not about just how many calories we're growing, it's about what kind of food, nutritious food with what environmental impact. And so this really allows us to have a more holistic assessment of this agri-ecosystem sustainability. Right now at 11:30 or 12, actually, in a half an hour, we're going to be launching the 5-year results of this project. So I will be stepping out to go into this next webinar, but we have a second webinar next week, October 7th, that you're certainly welcome to join. And then all of the results of our project, as well as some of the Light Farm trainings, are available online. We just want to close by talking about data governance. So a lot of digital agriculture is really focused on big data and lots of data throughput. And so as part of our project, we really have spent a lot of time thinking about ethical data governance. So making sure that farmers and their support organizations have sovereignty over their data, that their data is theirs to manage and to share as they see fit, and also that that data is always available to them and not just kind of taken away from their farms and used for other purposes. So we have a number of, as I mentioned, extension resources. So we developed an agroecological record keeping user guide, which is not just about digital agriculture, but about different ways to do agroecological record keeping. We're working on our exit to community and open source governance plan. So anybody who's interested in open source, happy to chat with you about that. And that's it. So you feel free to send me emails with questions about Light Farm or try it out. It is available online, and I'll close there. Thank you so much for having us.
All right, thank you, Dr. Whitman. And I say it's quite timely, probably even fitting, coming after agricultural census, because really important is how we collect data from the farm level. And I really appreciate the point on data governance, because now that we are digitizing, everyone's data becomes widely available, and knowing that your data is being protected and how it's being used is one of those issues that many of us face and queries that we have with about data, and I know our farmers do too. All right, I'm going to take 2 more presentations before I open the floor for questions. Is that okay? It will allow us to finish the drone presentations, and then allow us to then grab questions from the floor for the speakers that are here. So I'm going to invite now Mr. Sean Boyce and Ms. Courtney Ford to present from CIMH on drone applications for marine ecosystems management. Are you both online? And this is a shared presentation.
Yeah, I'm here. When you're ready. Just verify you can see my screen and you hear me clearly, please.
Yes, we can see your screen and we can hear you. And Ms. Ford is online with you as well. You're all in the same space.
All right, so it's actually Mr. Ford.
Sorry.
Test. Yep.
He is online. However, we also have some other collaborators that will be presenting. So when you're ready, we can get started.
Yes, you're welcome. The floor is yours.
Okay, thank you, Chair. Good day, colleagues. So my name is Sean Boyce. I'm the Chief Hydrologist at the Caribbean Institute for Meteorology and Hydrology. Some may perhaps wonder why it is that a hydrologist is giving a presentation on marine applications, other than the fact that they both relate to water. Nevertheless, my portfolio at CIMH also includes Earth observation applications, within which the drone program at CIMH sits. So we in particular tend to more focus on airborne type applications. However, from time to time, we do have collaborations with other research organizations and other entities in different areas. So the presentation today focuses on one of these collaborations that we have in this particular case with Caribe Goose, as well as the Rutgers University, the Center for Ocean Observation Leadership, looking at a marine application of a drone, in this case, what is called a glider, that has been going on for the last couple of months. So the collaboration is ongoing, and we will kind of speak to that as it relates to potential for drone applications in the marine space. All right, so just very quickly, in the interest of time, we at CIMH have many functions. I'll probably just focus very quickly on 4 of them. We are a regional training center as designated by the World Meteorological Organization, and through that, we try to integrate our research and development activities within our training. Our research and development is kind of focused mainly on meteorology, hydrology, climatology, and related sciences. And we also provide the region with some simulations, both on the climate and environmental side. So we do run our own numerical weather prediction models, both for the atmospheric space as well as the marine space as well. We do house the regional marine forecast support center. As I said, and many other functions. Perhaps you can visit our website at some time to peruse a bit more. So what I'm going to do at this time is to hand over to Doug. He is part of the IO Caribbean group. It's a body in the UNESCO focusing on the marine space, and he will speak to the collaboration that's ongoing as it relates to the deployment of a glider in the marine space in the vicinity of Barbados and surrounding islands. And then we'll come back later to kind of wrap up. So over to you, Doug.
Okay, yeah, thank you, Sean. Thank you, everyone. And Sean, yeah, I'll have you hit the slides if you don't mind.
Sure, no problem.
Okay, my name is Doug Wilson. I'm actually an oceanographer. I'm representing University of the Virgin Islands here in St. Thomas, U.S. Virgin Islands, but I'm also the project coordinator and for the Global Ocean Observing System component of IO Caribe, and that covers the entire Caribbean region. We call that GOOS. It's an intergovernmental IOC-led program, part of UNESCO. And basically, we, and particularly in the Caribbean, are trying to develop a ocean observing system to deliver essential information for sustainable development, safety, well-being, and prosperity. And, you know, how do we fit with agriculture? How do we fit with drones? You can see there, we try to use numerous tools in collecting ocean observations. And many of them now are autonomous tools. And so really, many of them are ocean-going data collecting drones, if you will. What I'm going to talk about today is one particular example that we're working with CIMH in Barbados and other groups in the Caribbean to expand. And here they are. We're going to talk about ocean gliders and other autonomous observing platforms. They're all critical components of GOOS. So next slide. So I'm going to show a little data here, and maybe this helps sort of drive home the point for all of the countries in the Caribbean, why we need to make ocean measurements, not just for ocean applications, but even for agricultural, economic, all sorts of applications. This upper left, what you see there, the blue track, that's the Caribbean, over the entire Caribbean average sea surface temperature from 1980 to 2025, the last 45 years, when we have high quality satellite measurements of SST. And if you take a mean, you see the seasonal signal. Of course, it gets colder and warmer with the seasons, but in the mean, the sea surface temperature across the entire Caribbean average has risen over 1 degree Celsius since 1981. And, you know, obviously, especially for small island states, the ocean temperature is highly dominating the air temperature and the climate. So that's a huge signal. The peak of that, at least when I made this graph earlier this year, the hottest week on record, these are weekly measurements, was October of 2024, almost a year ago to today. I have a feeling if I plotted this out up to today, it might even be warmer. But so what you see there, that last warmest record, if you move to the right, that's a map of the sea surface temperature over the entire Caribbean for that week. And I think one of the most interesting things there is that what you see is that red band that's essentially coming up through the southeastern Caribbean, through Barbados, through Trinidad, Grenada, that entire area. That's the warmest water in the Caribbean on that warmest day in history, right there. And there's two things going on. I mean, it is warm water. It's also fresh water. A lot of that water comes from the equatorial Atlantic, and a lot of it is influenced by the Amazon River output. It flows up the South American coast. So it's fresh water, and it's warm water. One of the reasons we look at that is the impact that it has on hurricane intensification. Both of those factors, a freshwater layer of warm water, can really impact how hurricanes intensify. Again, something we all care about, from agriculture to tourism to economics. The lower panel also shows why we care about it, particularly in this Southeastern Caribbean region. That is now looking at the trend, not just over the entire Caribbean, but for every little part, one little quarter-degree pixel. And I think the interesting thing there is that while the entire Caribbean is warming over those 45 years, the Southeastern Caribbean is warming faster than anywhere else in the Caribbean. So think about that. And think about, from an ocean observing standpoint, how we measure that. And that leads us to this project that we've been working with CIMH on the next slide, which is using ocean gliders. So ocean gliders are, think of it as an ocean going drone. We send it out. It's got instruments that can measure temperature, salinity, dissolved oxygen, currents in this case, and we'll mention that it can measure a lot more things in addition to that if we put those sensors on it. The cool thing about this drone is that we send it out. It's very efficient in the way it collects data. We send it out for months at a time. So we send it out, we tell it where to go. It goes down to 1,000 meters deep. It's measuring the entire upper ocean, comes back up, sends us the data roughly every 3 hours via satellite. We take that data, we put it out to the public on the internet. And one of the primary things we do is put it directly into hurricane models, for example. But it is available for all purposes for anyone to look at. This particular one we put out in July, mid-July. You see a group here from CIMH and Rutgers and myself from the University of the Virgin Islands, from IO-Carib. And we put this out just off the coast of Barbados for a 3-month mission to send down to as far south as Guyana, over to Trinidad, back to Barbados, just to look at how this, what the water flowing northward that we saw in the previous slides, a lot more about the temperature, salinity, and flow of that water. That was part of as you can see, a critical study region because of the impact of these observations on the tropical cyclones, but it's also part of what we'd like to do in IO-Caribe Goose, which is just more ocean observations within the Caribbean region. Next. So here's what we did. There's a picture of us deploying the glider in July off of a dive boat out of Barbados. There's a picture of the glider heading off on its 90-day plus mission. And there on the left is a picture of that mission to date. So we started in Barbados, we went south, other way, this other direction. So yeah, south, eastward, down, southward into the coast off Guyana, back up over to Tobago. And we are now actually back off the coast of Barbados, having done that section 2 or 3 times. And we'll be picking this glider up and collecting all the data in about 2 weeks off Barbados. So fantastic mission. It's worked out well so far. Those lines that you see on the map are actually modeled currents. And so, yeah, one of the things we've done is try to sample those particular currents, and by measuring in the upper 1,000 meters temperature, salinity, dissolved oxygen, and currents, we can verify the models and also look at the water mass properties that are moving into the Caribbean and causing these, region-wide changes, and as well as long-term climate changes. Next. So one of the things we want to do in IO-Caribe is expand this program, and essentially Barbados and CIMH are just one of many pilot programs that we're trying to do within the Caribbean. There's a lot of important areas that we want to measure, and you'll see ocean gliders in that southeast part in Barbados, up around where I am in Puerto Rico and the Virgin Islands. I'll be running a glider between Dominican Republic and Curacao a little later this month. We have another glider from Rutgers off of Jamaica. And our colleagues at CICESI in Mexico have gliders off of the Yucatan. So we're trying to measure these measurements all through the Caribbean. The other objects that you see on there are floats. Floats are also autonomous. They move up and down, similar to gliders, but they have no way of propelling themselves. So they simply go up and down and drift around with the currents. They're even more efficient than gliders. They only come up every 10 days, but they can last for periods of 5 years or more. So using these ocean-going drones, and I should also say that we're experimenting with autonomous surface vehicles, measuring sea surface temperature and pressure and other atmospheric variables. Sean may mention that there are CIMH and Barbados Weather Office and people like that are in fact doing that in Barbados. We're doing that in other places around the Caribbean. So more autonomous capability of ocean platforms collecting data that impact weather and climate. Next.
Hi,
And
colleagues, just checking on our timing.
Yeah, I know. Apologies for that.
We have half an hour to close, less than that. So
yeah, let me just say
let's do
quickly
2
on
minutes.
this one is that we can, because I'm going to turn it back to Sean and I don't want to cut him off. So hopefully he can wrap this up. But we do have the capability to use these gliders for a lot of different measurements that impact numerous things, maybe some of them more coastal, marine spatial planning and things like that, and fisheries. So Sean, my apologies for taking too long. Maybe you can wrap up.
Sure, no problem, Doug. Just to wrap up quickly, essentially, as pointed out by Doug, it is a collaboration. And the aim here is to kind of position, or further position CIMH as a Caribbean hub for these type of operations. So one of the things that we're looking to do is to deploy more drones, especially within the Caribbean region, and also to work with some of the young people and so on to kind of expose them to the technology. So what you're seeing here is a camp that we had over the summer where the campers had the opportunity to interact with the drone and actually were part of the deployment on the ocean. So I mean, given that Barbados is essentially at the edge of the Caribbean Sea in the Atlantic, it's a strategic location. But the long-term goal overall is to kind of build a glider fleet that deploys out of Barbados, given the strategic location, given that we do have some expertise at CIMH to maintain and sustain these types of initiatives. But just in closing, what I want to mention is that in terms of next steps, as I mentioned, that we're looking to establish a regional hub for glider deployment at CIMH. But to do this, we're looking to secure a bit more funding and some support to expand the program to the point where we can cover a lot more space and develop some of these integrated data platforms to help support the ocean modeling that we and others are doing for the region. Yeah, so as Doug pointed out, the data that's being collected is free and available for those who may want to integrate with other applications. So I will close there. Sorry for taking too long. For any questions, you could reach out. We can take a few now if time permits. Thank you very much, Chair.
Thank you.
Indulging. Over.
All right, thank you, Team CIMH. I mean, the session is going on. What I'm going to do, because we do have to change, and we still have quite a few speakers, I'm going to move on to the next presentation, which is also tied to the marine sector. At that point, we may be able to have a pause. There's a couple of questions. So I'm going to bring back to the floor Dr. Baldwin. She's going to be talking about using drone technology for sustainable fish production. And Kim, just same instruct guidelines, just to keep it as tight as we can, because we do have 4 additional speakers to speak. We will continue on this link this afternoon, but we will have a change out of moderators in about 20 minutes or so.
All right, can you see Are we good?
On her display? Okay, hold Kim, we're seeing a black box on your display. It's
Hmm.
blocking out part of your screen.
Okay,
Now
let's
we're
see.
seeing a whole black box.
Okay, hang on, escape. Let me start this over. Stop share.
Yeah, it's down to for me, it's my right-hand side, but I'm facing the screen. It might be. Or
Hmm.
the IT is suggesting you share the program as opposed to the screen. It was back there again. So if you share the full thing as yeah, the full, I don't know the idea. I don't
Higher
control.
screen.
Yeah, share the full screen, not the app. Oh, share the app, sorry, not the screen. Sorry.
Sorry.
IT, I know.
Share the application window. Content only. It's still,
It's coming up. 1 second.
Oh, it was. Sorry, I jumped the gun too soon.
Oh, yeah. Give us a internet time.
Share application.
It's still there. So we're gonna go on.
It's showing it now?
Oh goodness, it's even bigger. Okay. All right, let's go. Let's proceed.
You can see it, yes?
Yeah, let's go, Kim. We still has the block, but let's go ahead. Let me have you present.
Okay, see if this works.
You're going into presenters mode.
No. Oh gosh, I don't know what's going on here.
All right, go back to what you were doing just now.
Okay.
We'll go with that. It
All
will allow
right,
us
sorry.
because you did it before and
There.
I mean, we saw what we could. Yeah,
You're getting the screen or not?
don't worry. We are, oh, we're getting it. We're good to go. Let's go.
Okay, good. All right, so today CRFM has asked me to talk about an ecosystem approach to fisheries and how drone technology can help improve this approach. So EAF is a holistic strategy for fisheries management. It considers the entire ecosystem, including human interactions, to achieve sustainable and equitable uses of resources. A key principle of EAF is stakeholder participation in management of our fisheries resources. Today, most people know me as the drone mapping instructor, but I'm actually a fisheries biologist. My PhD was based on a participatory approach, building a participatory GIS for transboundary marine and fisheries resources in the Grenadines. In 2021, I also contributed to the EAF toolbox by developing participatory mapping methods to help managers implement this approach. In a nutshell, participatory GIS is a user-centered, demand-driven approach about obtaining good quality data, as well as the process of building capacity for people to participate in environmental management. Unfortunately, for many years, GIS was my bottleneck. It was very hard for me as a GIS lecturer to train people to use this let's say, tool, and therefore it really limited the true aspects of participatory GIS. But now, emerging technologies in the last 10 years, like drones and analysis tools, offer us exciting new ways that allow us to collect data and engage communities. So most of us today are very well aware that drones can help save us time, money, improve safety and accessibility, as well as provide timely and accurate data. But what sets them apart and what is central to my work over the last four benefits. Drones make data collection and participatory and transparent, can be used across sectors and scales, build local capacity and understanding, and are directly aligned with national commitments and global goals. To me, this is the most exciting aspect of drone technology. I refer to it as my participatory UAS approach, which supports both ecosystem approach to fisheries and co-management by merging local knowledge with scientific data that empowers stakeholders to monitor their environment and changes together and really ultimately builds trust and transparency in data collection as well as decision making. So why should we use drones in fisheries management? Drones help us quickly map habitats and critical resources, monitoring the abundance and behaviors of species as well as people. They can help us strengthen enforcement and surveillance, respond to disasters. They support search and rescue, and improve long-term management and planning. So to make these ideas concrete, I'm going to highlight a few rapid fire case studies. The first is here from Belize. So when you're developing drone mapping surveys, there's a whole variety of different flight surveys you can apply. And so really understanding the data needs and the stakeholders and starting from there and working your way back is the way I train my teams to approach this. Different types of drone data is more useful for different audiences and stakeholders. So really having people think in an ecosystem way is essential to this approach. Furthermore, rapid mapping and monitoring of essential fish habitats, livelihoods, as well as impacts to our environment is really useful and is essential for EAF and understanding the ecosystem context of fisheries. Here's another great example. This is from Anguilla. Drones are extremely valuable for monitoring climate resilience, vulnerability, adaptation. I had done this training in Anguilla for the Disaster Management Agency, and the day the training ended, Hurricane Tammy hit. We were able the next morning to go out and rapidly map the same area. This here on the left is where we had mapped during training, and we were able to go out the day after and map the area and send it remotely to, I believe it was CIMH up in Barbados, and allow for regional help as well as to the UK overseas territories, which was really quite useful. This is another great example from Barbados. So here, the team and I in Barbados, we had mapped this area, the Fisheries Division, this is Bridgetown, before Hurricane Beryl. That was 2022. You can see this is a panorama. Also, the Fisheries Division is able to inspect boats and vessels here in this image. And so this was quite useful. And then in 2024, Hurricane Beryl hit. And so here, I believe, I show you a screen share. On the right is the hurricane. So we were able, right after the hurricane, to get out and map the area and quantify the damages. So again, quite useful for monitoring changes over time. Furthermore, here's an example of video. So not just drone maps are useful. A lot of times you also need to have other multimedia. So here's just a video before in 2023 of the fisheries complex and infrastructure in Bridgetown. And then right here is the same area flown after Hurricane Beryl. So again, having a whole variety of information centrally stored in the cloud allows for national planning and decision making, but also regional access and information. And lastly, probably one of my favorite things is the fact that you can annotate these maps in a simple program. This is Drone Deploy, but export the data into GIS as well as have automated reports being built that can quantify and add up, as well as Excel tables, etc. It's really been a game changer, I find, for my students and countries. The next case study is looking at drones for inspection, surveillance, enforcement. These are two other projects that were conducted. I believe one was Canary and the other is the OECS drone training projects. So again, we looked at coastal resilience. We looked at coastal erosion. Both of these were done by fisheries officers themselves. The one on the left was looking at the fisheries infrastructure, both of them actually for planning new fisheries infrastructure and also assessing coastal changes as well as erosion issues. Another great example from the Bahamas, using it for surveillance enforcement. The Marine Resources Division, the enforcement agents were trained, and so they have now set up flight plans at key fisheries landing sites so they can use it to inspect and enforce, as well as the orange circles here were showing mooring damage from seagrass beds from boats. So being able to pinpoint and quantify and have accurate data has really been quite useful. And the fact that this program is very easy to use. Here's another great example from St. Vincent and the Grenadines. This is an FAO project. And so the Ministry of Agriculture, this is the entire south coast of St. Vincent. The team, which comprised of pilots and data analysts, worked together to create a disaster risk management map. And this map was able to be integrated, as you can see on the right, with the existing national GIS data sets and used for planning and development of marine spatial plans and the marine management agent area on the south coast of St. Vincent. So fisheries management benefits and opportunities. Really, there are so many, but the integration of drones into fisheries management offers us many tangible benefits. The first is timely, high-resolution data that can feed into evidence-based policy making. Having up-to-date maps and imagery makes the process more scientific and transparent. In short, better data leads to better outcomes. The next is cost-effective monitoring. We all have budget constraints. Traditional fisheries research is quite expensive. In contrast, the price of a drone and training for personnel can perform routine monitoring at a fraction of the cost. Furthermore, cloud-based platforms allow us to work at multiple scales and levels, from the scale and level of a local community to the nation, to the region, as well as globally. Probably what excites me the most is the building or the embracing of technology with the benefit, and people say it's a side benefit, but I see this as a main benefit, upskilling staff and engaging people and stakeholders by having training programs for fisheries officers, park rangers, and community groups. And I think what I want to emphasize here is the merging, and many of the projects that I've worked with train both the community groups and the fisheries government agencies together. And that collaborative management has really been a game changer. It allows people to apply these skills for fisheries and agriculture, as well as have alternative livelihoods. And so really, this isn't just about fisheries, but all sectors can use this data. The approach that I train can be re-leveraged, whether it's for disaster management, agriculture, forestry, or fisheries. This is truly a win-win for countries and development. By aligning with both broader national and policy goals, it can help contribute to the blue economy, food security, and improve sustainable management of our resources. So, in conclusion, drones are so much more than a cool gadget. They represent a practical innovation to advance an ecosystem approach to fisheries. By providing better environmental data, engaging communities, and enhancing and management effectiveness, drone technology addresses both ecological and human dimensions of fisheries sustainability. These case studies from around the region and beyond show that this is not theoretical. It's already happening with impressive results. So together, let's advance EAF with drones and ensure our fisheries are sustainable and resilient for generations to come. I have to thank all of the various different people that have worked together with me, and I really want to emphasize the point of the collaborative information generation, but also sharing of this information. I think is probably one of the most important pieces. And thank you very much.
Thank you, Dr. Baldwin. So we've heard quite a bit in our session. I'm going to pause here for a couple of questions while we have a continuous, and we have two more speakers to come. But we have one question online. Okay, I can switch mic. While we take one question online, the break should be outside between 3 and 3:30 for those who are physically here with us. But we're going to keep going, just to let you know. So you may have your break or come back in the room so that we'll move forward. No question. Okay. All right. Let me just check in. So I do see a question in the room. So let's start there while we locate the other.
Hi, good afternoon. Thanks for the presentations. I thought they were really very interesting. And my name is Melissa Brown. I work at the World Bank. And yesterday we had a session on food security and data that was led by FAO and WFP. And one of the questions in that session was how to integrate all these different sources of data. So we think that sometimes there's not enough data, or there is a lot of data, but it's actually in different bits and pieces. And so this is a very nice set of presentations about how to generate data with new types of technologies. And then, so I guess the question is from the presenters, what do you think and how are we able to integrate this data into the statistical systems and the other data and information systems at the country level, and then I guess at the regional level as well?
All right, thank you. I might want, okay, before and I know who I would like to ask both him and the team from CIMH on this point of how we integrated international data existing systems, given what has been presented. I don't know if Dr. Whitman is online because she had more of the field side and how that extension data gets incorporated. I think she had to leave. But can I just take the second question, the other question too? So I have, oh, it was answered online. Okay, thank you. All right, thank you. All right, so Dr. Baldwin, if I go to you first, and then I'll come back to the team from CIMH.
Yeah, could you just repeat the question? It's so how can this be integrated within
Yeah.
national? Okay, that's a really good
Yes,
question.
we'll bring the data into national data systems.
This is really the bottleneck at this point. I've worked on so many projects across 15 different countries in the Caribbean. And so really it's I'd say that this is probably our biggest bottleneck at this point. It's how do the countries are all working at different scales and levels. Most countries don't have national cloud-based servers with all of their data. So they are siloed into different organizations. I would say that this is really, I would love to hear what CMH has it. When I work together with a country, let's say we're going to work with the Ministry of Agriculture or Fisheries, we'll sit down and we reach out to all the government agencies as part of our data scoping at the beginning of the project, find out what data they're collecting, how they're sharing it, what data protocols they have. As you know, with GIS data, it is a bag full, right? So having a one size fits all approach, I don't see quite happening yet. But it really, I think where a lot of countries struggle, at least based on my experience, is having that national infrastructure in place for GIS data, sharing amongst the agencies. So this is why we're using Drone Deploy. This is why we're using those cloud-based platforms, because most countries that I've worked with don't have the national infrastructure in place. They don't have the servers. They don't have it built that they can easily share amongst the different ministries and agencies. So that really provides a problem. The technology is there, but I think some time and effort needs to be put into, again, this is why I changed my career, training and capacity building for people to adequately use and handle this data. People are getting really carried away right now in the drone world with LiDAR data, and LiDAR data is great, but if you don't know what to do with it and you can't manage it, let's start. And so my approach is start small and build the capacity to use this data and information. But I think the servers and the ability to store it and share it nationally, in my opinion, that's where we need to focus next.
All right, thank you, Dr. Baldwin. I go to Team CIMH, Mr. Boyce and Mr. Wilson.
Sure. I will start. Yes, I mean it's a very good question. I mean, if data are collected but it's not available, is it useful? Essentially, is what it comes down to. For us at CIMH, we always encourage interoperability. We do have existing platforms that we use to kind of manage spatial data sets, and as much as possible, we try to integrate what we're doing into that space and provide access to our downstream users. I mean, as a regional organization, we do have a footprint in about 16 member countries across the Caribbean, and we try to encourage them to promote open data policies. At the end of the day, making the data available encourages research and development and so on across the board. So for me, it's about open data and making the data that's being collected accessible and trying to promote these open data policies. As it relates to the the Glide data, I mean, data is actually available online. It's free as far as I'm aware for persons to use and I guess develop, applied in other areas. And as a regional organization, we do have, I guess, some level of resources that enable us to kind of develop these types of data sharing arrangements. However, it comes back down to the being having access rather to the data that is out there. So essentially, it comes back down to interoperability and open data policies. I'm not sure if Doug want to add anything to that. You can if you wish.
Well, I'm going last, so you guys did well. And so it is an under stressed aspect of capacity building. And it's really when we look at an observing system, it's actually the first thing that we stress is the data collection, integration, and sharing system, and standardizing that across all the different people collecting data so that it can be shared. And once you've developed the capability to share it, then you have to work with the various groups collecting data to actually be willing to share it. So that's part two. And yeah, I mean, those, if you can do that, then we've made many steps, but it's a often difficult. And I can't remember who was the question from? I think it was like World Bank or it was somebody like that,
Yes,
right?
Ms. Brown
Yeah.
from the World Bank. Yes.
Yeah, right. I mean, so the difficulty is
Okay,
yes,
thank you, Colin.
aggregating all that and getting it to the people who need to know, like that can act on it, like World Bank. Yeah.
All right, thank you very much. We're going to continue with the presentations. Yes, sorry, we have to move just because we have so many others to come on in the next session. I will also be leaving you as your moderator and switching over to Mr. Shah as I switch another session. But I am going to introduce Dr. Winston Dawes, a senior economist, agriculture economist in agriculture and food global practices of Latin America and the Caribbean, based at the World Bank, to bring our next presentation. And Dr. Dawes is going to be speaking about smart farming for agriculture, for agricultural development in the Caribbean. It's the first one, yes, please.
All right, good afternoon, everyone. My name is Winston Dawes. I'm with the World Bank, a senior economist with the World Bank in the Agriculture Caribbean, in the Latin American Caribbean region. So this presentation is actually a collaborative work where we received funding from the Korea Green Road Fund. And it's again in collaboration with the World Bank, where we're looking to do pretty much an analytical work. So it's not an actual project, it's an analytical work where we're testing out to do an assessment to see different approach, different models to agriculture. And one of which is called smart farming. We all know that we need to increase agricultural productivity, especially within the Caribbean. We have different limited land size, and then we have various vulnerabilities. And so therefore the approach to agriculture obviously needs to change. Similar other countries have been doing it in other places. And so the idea was to see how this model could also fit within the Caribbean. Part of this task, we actually took a team of ministry officials and the farmers from Jamaica and Dominica. Dominica seems to be a popular country. They took some for the drone I saw for training. We're in the Dominica room, by the way, just for those who notice. So this is some of the findings coming out of that. All right, so the first thing here, when we talk about smart farming is probably people may want to know what's the difference with smart farming versus climate smart agriculture, precision agriculture. There are a lot of terms being bandied around. So in terms of climate smart, I mean, it's basically what most of you probably know is an approach to transforming agricultural food systems, especially given new realities of climate change. While when you look at smart farming, we're actually looking at an approach of more using technology, more of it is a technology driven, where we're using a lot of modems, sensors, Internet of Things, to increase the quality, of course, and also the quantity of the products. Clearly, when you talk about climate smart, if there's a focus on sustainability, when we're looking at smart farming, the more focus is more on efficiency use of technology, where, as I said, using GPS drones. Of course, sessions we were talking about drones, and other analytical tools to help be able to control the environment that which you're working with. Of course, at the end of the day, the benefits will be, of course, increase farm productivity, reliance. Again, with smart farming, you could also have reduced labor, because of course that's a challenge we see in the Caribbean in terms of labor. And then, of course, you optimize your outputs. Every smart farming approach tends to have the model, and we're going to go to a little bit about the models, but they tend to have a similar makeup. One, you need to have a set of data collection approach, which is where you use the sensors to collect the data around temperature, humidity, soil type, fertigation, water, etc. Then you look in also then to process that data of what you collect, and then you analyze that data, which helps make better decisions in terms of going forward, forecasting, and based on the growth projections, based on what's actually happening within the environment that is being controlled. And then from that, obviously, you have a response, action to be taken. A lot of this in smart farming is actually even automated, where, again, this is where we're using a lot of robotics and sensors to turn on and off switches, etc., to be able to control the environment in which the crops that is being grown. In a nutshell, when you look at smart farming, they're obviously in everything, there are pros and there are cons. Clearly, couple of the pros is that because you're using technology, a lot of the sensors for humidity, for light, you'll be able to reduce in exposure to disease. You have obviously, you get higher yields. You're more resilient to climate change. And also you have in terms of better risk management, because you can control the environment. So you're better control of the environment, external environment, because you're working in a much more controlled environment. Then it's obvious some of it is automated, which then helps you to have uniform quality of output, uniform quality of the environment, and then also have lower costs. In terms of labor costs, labor resources, inputs, you can control the amount of fertilizer or inputs, the amount of water, sunlight, etc. So you have a better control of your environment and less waste. One of the challenges, of course, with smart farming is the challenge around cost. There's an initial startup cost. Professor in the very, very first presentation indicated that there is a cost for getting started. There also needs to have access to efficient energy supply. Then there's some amount of training, capacity building that is needed. For smart farming, we can look at it probably. Somebody say, well, is this suitable for smallholders? There are aspects of it that could be suitable, but a lot of times it's actually targeted for a little bit more larger farms or say larger cooperatives that can afford at least the initial startup cost. Is this smart farming advisable for the Caribbean? I think the answer is yes. In fact, that's why we're in this session. There is need clearly for increased yields, clearly for better consistent production. The management of the outputs within the Caribbean environment is needed. So smart farming is definitely something that we should pursue. It also has, how we have limited labor supply, so we can, of course, need to, with smart farming, you can still get significant yields with reduced labor. The climate within the Caribbean, definitely suitable. There are areas where there are high elevation, so you can actually, and given the temperature, we are in the tropics, we can tap into solar. There's a huge demand locally, both because of within the tourist industry as well as local demand for produce. And then in terms of we are susceptible to hurricanes, extreme weathers, but with a climate smart environment, you have more control over that. So it is one method of managing your consistency, and you're protecting your agricultural production. Now, climate smart farming does require a fair amount of what you call enablers in order for it to be successful. This is something that you do not just jump head on in, because it will not be obviously successful. You clearly need one area is that you need good market linkage, because you will be focusing a lot on more high value crops, whether that be things like strawberries, lettuce, tomatoes, peppers. These are niche crops, high value, but you want to ensure that once you produce them, you have a market where you can, because your production will increase, and so you don't want to have spoilage, wastage. So you need to tap into having a clear market linkage to take off the supply that's going to come. In terms of resources, you need, as I mentioned before, energy resource, whether that be solar, diesel, some type of generator to ensure you have consistent energy supply, water, irrigation, and some level of storage for your produce. In terms of facility, the resilient facility design, most climate smart facilities come in modular types, whether that be container, whether that be glass, greenhouse, climate controlled buildings. So there are different forms, and most times they can be scaled. In fact, as we talked about the last one, achieving the economy of scale. As your climate smart facility grows and expands, you can add modules. So a lot of times they're in a modular form. These were just, as I mentioned before, the funding and support for this was from the Korea Green Growth Fund. And as I said, a group went to Korea, and these are some examples of what smart farming at a large scale looks like. The kinds of yields are much significant, anywhere 10, 20 times you normally would get from regular outdoor farming. A lot of this is all remote driven, robots, or just sensors. So very limited labor, but this covers over 7,000 hectares. So it is a massive area of controlled greenhousing. This is a similar example, more of a container, more vertical farming. Again, but the yields and the kinds of outputs are significant, and they're very specific, whether that be strawberries, looking at mushrooms, cilantro, or herbs. And they have linkage, as we talk about, you need to have great off-takers, markets. So a lot of their produce are all bought by KFC, Starbucks, Burger King, etc., and markets, and a lot of supermarket chains. So these go hand in hand with the increased production, efficiency. You have to have them go along with it. So these are just different types. Well, most of you probably may have heard some of these: vertical farming. We know of the traditional greenhouse, which is more of a low budget type of greenhouse, container farming, interior farms, which is basically a controlled building. So these are all variations of smart farming. The challenge is how you have to outfit them. As I mentioned, they all have to have the initial inputs of the data, sensors, the lighting, these are controls, and then to process it, and analyze the data coming out of it. And yields, in all cases, you do get significant yields over traditional farming. Now, again, if you're looking at see whether how a smallholder who has a greenhouse, can he benefit from smart farming? And the answer is yes, because they can start relatively small. Simple things like the solar radiation sensor, which controls, he looks at temperature, rainfalls, humidity. You can also bring in simple drip controllers and fertigation facilities. So these are basic technologies, all part of smart farming, which some people have been using, but the important thing is that I think we need to increase usage of this method of farming within the Caribbean. One of the reasons why Korea has expanded significantly in use of smart farming is that in terms of the 50 million population, the land size is limited, and so therefore they couldn't expand more in terms of large acreage of agriculture cultivation. So they turned a lot to using technology to get similar yields, if not greater yields, to feed its population, as well as for export purposes. So I think this is an area that we need to explore further. We're going to provide some further analytics in terms of the costing, the kinds of overall yields, specifically that will be applicable to the Caribbean. So the research is not yet completed, but this is an area that ties in very well with the drone technology that's being discussed this morning, fisheries. But this is just one other element in terms of from a crop production standpoint, where we see technology along with the appropriate use and management of inputs can really result in significant outputs and yields for the Caribbean and local production. So I'll stop here because I know we've been having a lot of different presentations. And yep, thank you.
Okay, thanks, Mr. Dawes, for that presentation, highlighting the benefits of smart farming and coming up with an appropriate model for the Caribbean. So we look forward to this project that is ongoing and really should be implemented soon. So at this stage, colleagues, and for the online participants, we have one more presentation. So let me invite, and then what will happen is that the digital session will continue. We will just break for 5 minutes because we have an interesting second session. In this first session, we would have dealt with many of the applications of drones, of smart farming, of some of the apps that can be applied in our situation here in our agri-food systems. But in the second session, we'll be actually looking at actual uses of sensors, of applications in our second session. But let us finish up this first session, and let me invite online, and then after I will call on CDB to bring a few remarks, but let me invite Ms. Laura McNeil. She is the CEO of, I believe it's a community hub, and she's doing a presentation on introducing your farmer community digital advisory support for small-scale farmers. So Laura, you'll have 10 minutes to present to us on the model. Over to you.
Thank you. Thanks. Welcome, everyone. Can you see my screen?
Yes, we are.
Excellent. Okay. And I promise not to take more than 10 minutes. I know we're running behind. So hi, everybody. My name is Laura McNeil, and I'm the founder of Carob Farm. And we're an early stage social impact startup. And Farmer Community is our knowledge sharing app. And did you know 550 million family farms produce about 80% of the world's food? And about 3/4 of these farmers have already seen major impacts due to climate change. Farmers need climate smart solutions, and they need them now. Whoops. My Uncle Joe was one of those farmers back in his day when he discovered a pest infestation in his crops. He just picked up the phone and called Sam. Sam was his local advisor in the agriculture department, Uncle Joe depended on Sam to troubleshoot his problems and provide easy to follow solutions. But things have changed. The evolution of farm advisory services has been global, leaving an information gap just when farmers are struggling to adapt to increasing climate change. Today's farmers want direct access to research-based guidance for crops and livestock, on-farm troubleshooting, and support for new technology and innovation. So the Farmer Community app revolutionizes how farmers receive advice. We connect farmers to one another, to our team of international agriculture experts, and our extensive knowledge library of videos and collections from around the globe. Farmers ask questions and they get answers. So what's the secret? Well, we partner with leading agriculture universities and international research organizations. They share their cutting edge technology and research with us, and we share it with the farmers. And our business model is pretty simple. Our users are the farmers, and our customers are farm suppliers like seeds, fertilizers, tractors, and equipment, service providers like finance and crop insurance. And with the help of this top-notch team of international experts, I've been able to bootstrap our 4-year progress. These folks are farm advisors, plant pathology PhDs, agriculture data specialists, postdoc fellow in controlled agriculture, a couple of masters in innovation and entrepreneurship, tech and partnership development experts, and a 25-year veteran with the FAO. All volunteers, all supporting the mission. In the farmer community, digital solution addresses over half of the world's SDGs. What we're seeking is capital, partnerships, and collaborations to scale our existing pilot project. Now, together, let's show you where you can sign up and learn more. So if you take your mobile phone and scan the QR code, or you can simply type Carib, C-A-R-I-B, .farm. We can do this together for those of you who are interested. Yeah. So after typing Carib.farm or scanning the QR code, you should arrive here at the Carib Farm website. It looks like this. One of these is a mobile version, and the other one looks like what it would be on your desktop or laptop. So you click the button here, Join Community. And that's going to take you here. This is the Farmer Community information page. So there's lots of info about what we're doing. But for today, what you want to do is just click on the sign up, or at the bottom, the little green button, if you scroll down, says Join Community. And this is for folks who want to sign up or are interested in taking a closer look. Okay, so when you click that button, you're going to see this sign up form. So it's really simple. You just complete all the boxes and then hit the send button. And that's it. What happens then is your request lands in our inbox and it will be reviewed. And then after which you'll be sent your login details. It usually takes a couple of days, and really it depends on how many requests we get. So what I was thinking now is we can take a little peek at what you can expect if you join the farmer community. Okay. So we're just going to play this video, and let me just make sure that I've shared the sound. Share computer sound. Okay, good. All right.
Here we go. This is the farm.
Can you hear it? Anybody?
Farmer
Yes.
Community app. As you can
Proceed.
see, on a mobile phone.
Not so loud.
Of course, it's always available on laptop or desktop as well, but most people use their phone. This is our home feed. You can see that there are posts here. This is the post about our session that we're doing today here at the Caribbean Week of Agriculture. And let's go down. So it kind of looks like Facebook. And let's go down to the bottom. So down at the bottom left, you'll see the little house, and that's where we are now. That's home, right? And then the next button is the messages center. So you can just choose another member and send a message. It's really easy. You just click on their name. And center button is a profile. A little bit about each person, and this is my profile, of course. The next button with the bell icon, this is notifications, and it's really important here that you turn on your notifications. That means that people can send you messages, you can send messages, and you get the alerts from us about posts and upcoming events and things like that. The next and last icon at the bottom right, 3 lines, is what's referred to as a hamburger menu. So we're going to click on that menu. And here you'll see that there's a member directory, listing of events, but most importantly is the library. So we're going to click on the library. Right. And here's our library. We have agriculture collections and agriculture videos. So let's just take a quick peek. So here in the ag collections section, we have crop, livestock, pest management, protected ag. Let's look here. So you'll see there's a long list, alphabetical list of various different crops with information about growing and managing them. And then we're just going to go back again and take a quick peek at agri videos. So there's a big long list of videos here. These were donated by our knowledge partners, international research organizations, and universities. All of this information is vetted. So if we look at seedling production, we have a bunch of videos in here, part 1, 2, 3, and 4. And if we choose one of these videos, you just automatically play it in the app. So this is seedling production part 1. It's really straightforward. Just push the play button and there you go. So that's basically it. And if there's anybody who would like to talk about how we could incorporate using the app with your farming organization, I'm going to leave my information in the chat and let's get in touch. Thanks.
Thank you so
There you
much
go.
for being on
Thanks.
time.
I just want to put this screen up, and I haven't done my 10 minutes yet. So for an invite to a follow-up session, you just can email us. The email address is pretty simple. It's info@carib.farm, and I'll put that in the chat. And here's my contact information for anybody who wants to reach out directly. And thank you very much for your time and attention. I appreciate it.
All right. Thank you very much, Laura. I think it's very useful as well, farm to farm, communication between farmers. We encourage you to, I know you have 1 or 2 Caribbean persons as your experts, but we encourage you to have some additional experts as well on your team who will be providing solutions on the app. But thank you again. Let me quickly, as we come to the end, I want to invite Mr. Malcolm Wallace, just for 1 minute or 2, just to bring some remarks on the knowledge management platform that the Caribbean Development Bank would have been working on, at the end. So Malcolm, for 2 minutes.
Thanks, Riaz. Yeah, hi, good afternoon, colleagues. Very quickly, the Caribbean Development Bank is piloting what we call the Caribbean Agriculture Knowledge Portal. It's a portal that intends to democratize agricultural information and support agricultural extension. We had a very interesting session this morning where we spoke to other colleagues from the FAO, ICA and CADI, and we discussed how we can collaborate to actually build the platform. Importantly, the FAO financed research that spoke to the development of a learning management system for the Caribbean. The current system that we have, it's a content management system, and the intention is to merge both of them together so that we can have a full platform that provides agricultural information for all the stakeholders across the region. I can provide additional details on that, Fires, but I do not have a lot of time like you actually mentioned. Just one comment in terms of what we're discussing here, digital solutions for agriculture. I think one of the key things that we need to take into consideration is that we apply technologies that are fit for purpose. Most times, we see a lot of things being presented in the region, but they're not actually fit for purpose. They don't actually help us to solve the problems that we have. So a key thing moving forward is that we apply technology that is fit for purpose and technology that can actually move the needle. I will end here. I think I have a few questions, but I'll turn it over to you. Thanks.
Okay, thank you so much. So I'll take 2 questions. Any questions online? And from the physical participants, anyone has any questions for the presenters? All right. So no questions. But Malcolm ended it up the way we would like to start the next session, which is that it has to be fit for purpose. And as we go into the next session, which should start in about 5 minutes for the online participants, so we'll give you a break now for 5 minutes, and we invite everyone to rejoin us. I want to thank all of the online participants. We started off late, unfortunately, almost at 2. But thank you for bringing your perspectives, and you know, feel free. The presentations will be available. You can visit the CARDI's YouTube channel, and you can get a copy of the presentations that were done. All right, so thanks everyone, and please stay on for the physical participants. Take a break outside, come back in 5 minutes, and hear some more interesting presentations on digital applications. Thank you very much, everyone.
Overnight.